Okay, today I will try to use a whiteboard. I don't know which one to share. I try this. Okay. I don't know whether you can see. Oh, how? Why it come here? I don't think I can put in app. Now is it got two? Very confusing. U1 is what? What's a U1? Can see the whiteboard? Someone on the mic?
Yes, can, teacher.
Ayo, what's happening? A bit slow. Okay, this is the one that I have given you in the WhatsApp. Okay, we look at the first questions, the first example. Okay, some of you maybe have tried. Okay. Okay, 4 points are given. Okay, these 4 points are the vertices of a quadrilateral. Someone is moving my... And you all don't touch. Tell me how to stop. You don't cooperate with it, or you want to put it in the middle, is it? No, I want to write, so I want to put it at the side. Ayo, who is drawing the flower? Don't draw. My goodness. Can I start? Can I start? You all don't touch the screen, huh? Okay, find the equation of a PR, okay, and then the QS. Okay, you have 2 points, huh? Okay, so how to find the equations? Okay, this is number 1A. Okay, you can use the formula of y minus y1 equals to over x minus x1, and then y2 minus y1, x2 minus x1. Okay, you can straight away use this formula. Okay, P and R, this point and this point, okay, you can set either one is a x1, this is x1, okay, y1, okay, this is x2, y2, okay, P and R. Okay, this formula, if you're not sure is from where, okay, actually this is the gradient. You see, this is a formula for gradient. Okay, so this is actually the y minus y1 equals to gradient m, okay, x minus x1, this formula. Okay, if not, then you do step by step. First you find the gradient, then only you apply into this formula also can. Okay, so y minus, okay, y1 is 6, x minus x1 is a -8. Okay, now -2 is a y2 minus 6. Okay, x2 is 16 minus -8. Okay, so you do This one become positive. This is 8. This is 24. Correct? Oh, okay, so this one will give you a negative 1/3. Okay, then cross multiply. Okay, so if you cross multiply times 3. Okay, the negative I give to the 1. Okay, so 3 I bring it here. So negative 1 times 8. Yes?
We have to write this in our book or not?
If you didn't do yet,
Okay.
then you can copy. Okay, if you have done already, you just check your answer. Okay, okay, so I continue. Okay, so 3y. If I make any mistake, please let me know. Sometime, okay, 8. Okay, so now is 3y. Okay, I bring this to this side. So is negative 8. So this is plus 18 minus 8, so positive 10. Okay, so this is the answer. You can just leave it in this way because the question didn't tell you in what form they want. Okay, so this is one. How do I move this? Okay. Okay, this is 1A for the PR. Okay, this is equation PR. Equations PR. Okay, now we have the equations QS. Okay, equations QS. Okay, so the same thing, QS. Okay, I'm going to use a same formula. Okay, now, you see, and I move the x2, y2, all will not follow, or just now because I moved the diagram. Okay, now Q and S. Okay, so this is my x1, y1. Okay, now this is the x2 and y2. Okay, so y minus 8, x minus x1 is 6. Okay, then y2 is negative 4 minus 8. x2 is 2 minus 6. Okay. So this is a negative 12. This is negative 4. So I will getting positive 3. Okay, so y minus 8 equals, okay, the x minus 6, I bring this side. Okay, so this one plus 8, positive 2. Okay, I think this one at the end I need to use the gradient. Wait, let me see. Okay. Okay, show that the PQRS is a rhombus. PQRS is a rhombus for part B. Okay, you see the hints here. The diagonal of a rhombus always intersect each other at a right angle. Okay, this one you can go and search internet. What is the properties of the rhombus? Okay, this one you must always remember all these type of properties. Okay, so for a rhombus, the diagonal will intersect each other at a right angle. If you can prove the diagonals, okay, mean that two lines, okay, they are intersect each other at a right angle, then you can prove this is a rhombus. This is the meaning. Okay, if you don't know these properties, then difficult. Okay, so for me to prove they are intersect at a right angle means I have to prove their gradient. Okay, m1 times m2 is negative 1. Yeah, someone on the
I cannot see the board. Just now times 3. I thought it's 3x minus 18 because 3 have to times x and times 6.
Thank you. This is 18. Okay, then after that, this is plus 8. So this is minus 10. Not correct? Is it not correct? Who's that just now corrected me?
Teacher, I'm Yenny.
Yenny, correct now?
Yeah, I think so.
Don't think so? Never mind, okay? Okay, thanks for helping. The rest, please, don't fall to sleep. Okay, it's good I make mistake so that you are aware. Okay, okay. So I need to have both the how to say the gradient. Okay, so these are already in gradient form. Okay, so this is the gradient. Okay, the 3 is the gradient, but this one is not in gradient form yet. Okay, so I need to divide by 3 every terms. Okay, and then this is the gradient. Okay, so let's say M1 is this. Okay, M2 is this. Okay, so I just get M1 times M2. Okay, this is part B already. Okay, then I get -1. Okay, so you can see, okay, proven. Okay, PQRS. It's a rhombus. Okay, so this is how you prove it. Okay, so now we go to number 2. Okay, number 2. Then I go down. Sorry, I'm not very good yet in using this whiteboard. Okay, this is number 2. Okay, this number 2 is regarding the midpoint theorem. Okay, now we see. Okay, you have triangle. Okay, first of all, you have to find the midpoint of AB and the AC. This is part A. Okay, and then the midpoint of AB. Okay, here given is M. Okay, and then midpoint of AC. Okay, given here is N. Okay, now we start number 2. Okay, A. Okay, so M is the midpoint of AB. So I get the midpoint of AB. So 6 minus 2 divided by 2. Okay, for the x coordinate. Okay, 8 plus 4. Okay, divided by 2 for the y coordinate. 4 divided by 2 is 2. 12 divided by 2 is 6. Okay, now we see N. Okay, N is the midpoint of a AC. Okay, A and C. Okay, so 6 plus 4 divided by 2. And then 8 minus 12 divided by 2. Okay, this is 10, so this is 5. So this is a -4, so this is -2. Okay, next, you have to show the MN is parallel to BC. Okay, how you want to show they are parallel? Okay, you can use a gradient. Okay, so I just find the gradient of the MN, then I just find the gradient of the BC. Okay, if they are the same, then they are parallel. Okay, so gradient is it gradient? I sorry, I don't write M, capital letter M. I write small m, right? Should be. Like that. Okay, eraser. You, how to erase? Okay, sorry. Okay, gradient. Okay, this is part B already. Okay, gradient for MN. Okay, so y2 minus y1. So 6 minus -2. X2 minus x1. 2 minus 5. Okay, this is 8, this is -3, so it's -8/3. Okay, remember final answer, the negative put at the side, don't put at the bottom as a denominator. Okay, they don't accept this as final answer. Okay, another gradient. Okay, gradient for BC. Okay, BC, so I use a -12 minus 4. Okay, 4 minus -2. This is -16. This is 6. Okay, divide by 2. Okay, so they are the same. Okay, so you can say, yes, since gradient mn is equal to a gradient bc, therefore, okay, mn is parallel to bc. Okay, therefore proven the midpoint theorem is true. Okay, what is this midpoint theorem? Okay, now we go back to this. I think you cannot see this because I'm sharing the whiteboard only. You can see my words document or not? Aya. How now can see? Come on the mic.
Can.
Okay, so now we see what is this midpoint theorem. Okay, all these are actually extra knowledge for you, okay, but it's useful. Okay, so the midpoint theorem states that the segment are joining two sides of a triangle at the midpoint. For those sides is parallel to the third side and is half the length of the third side. Okay, this is the midpoint theorem. Okay, midpoint theorem saying that, okay, this line that join the midpoint, okay, of a two side, okay, will be parallel to the third side. Okay, means RS, okay, is parallel to TV. Okay, R is the midpoint of AT. S is the midpoint of the AV. Okay, and then another properties is RS is half the length of the third side. So RS is half of the TV. Okay, so this is a midpoint theorem. Okay, this indicates that point R and S are the midpoint of this. Okay, from the midpoint theorem, since the segment RS connects the two sides at the midpoint, then RS is parallel to TV. Okay, RS is 1/2 the length of the. Okay, so this is midpoint theorem. Okay, RS is parallel to TV, and then RS is 1/2 the length of the TV. Okay, if this one actually I get it from here. Okay, if you want to read more, you can see this. Okay, website. So after I will ask you to apply this midpoint theorem in one of our textbook questions that didn't, the textbook didn't use this midpoint theorem to do, but I want you to try to apply this, okay, and get the same answer lah. Okay. Okay, so this is a midpoint theorem. Okay, now we come back to textbook. Okay, so we have this today area of polygons. Okay, this is your index for today. Today is 8. Okay, this derive the formula for area of triangles. Okay, we can use formula to find the area of a polygon on the Cartesian plane if the vertices are known. Okay, so if the question give you the all the coordinates, okay, of all the points, okay, of the all the vertices, okay, we start with triangles. Okay, after we will go to a quadrilateral and then any of the polygons. Okay, so we start with triangle. If all the points are all the vertices, okay, the coordinate are given. Okay, you can use a formula, okay, and then get the triangle, the area of the triangle. Okay. Okay, we just look at this. Okay, you look at this diagram. Okay, how they get this formula? Okay, we see here. Okay, we want to find the area of this triangle ABC. Okay, so first of all, okay, you see this area of a triangle ACD. ACD. Okay, this triangle. Okay, plus area of trapezium BCDE. Okay, this one plus this one, and then minus out this one. Okay, maybe I use highlight. Okay, sorry. Ayo. What's happening? Okay, sorry. Okay, this is blue. Okay, I trace. Okay, so first of all, this triangle plus this trapezium. Okay, then okay, you minus the blue one, okay, minus the red one. Okay, then the balance will be the triangle ABC. Okay, the area of the ABC. Okay, so now one by one, we want to find this. Okay, so first of all, this triangle, the blue color triangle. Okay, so we want to find the area. Okay, this triangle we use our normal formula. Okay, half times the base times the height. Okay, so this is a base and this is a height. Okay, so the base is, you can use the x coordinate, the x coordinate here minus here. Okay, this minus this. Okay, so it's x3 minus x1. Okay, x3 minus x1. Okay, then the height is here, from here to here. Okay, so you can use a y coordinate for this and the y coordinate for this. So y3 minus y1. Okay, y3 minus y1. Okay, so this is the base and this is the height. Okay, next, this is the trapezium. Okay, this is a trapezium where, okay, if for trapezium, you have to recognize, okay, which two sides are the parallel one. Okay, so these and these are the parallel one. Okay, so these two you have to add. Okay, and then times the height. Height here will be this. This one will be the height of the trapezium. Okay, the height always make 90 degrees with the two parallel sides. This one all you have to recognize before you start. Okay, so for the height, okay, use the x value for these two. Okay, these 2 points, the x value. So x2 minus x3. Okay, x2 minus x3. This is the height. Okay, and then this one is the two parallel side. Okay, so the first parallel side, this and this. Okay, so this is the y value, so y3, okay, minus y1. Okay, y3 minus y1. Okay, and then the second parallel side is this. Okay, this is y2 minus y1. Y2 minus y1. Okay, so this is the area of trapezium. After that, minus area of this triangle, the red color triangle. Okay, same thing. This one will be the base and this one will be the height. Okay, the base here, okay, use this, the x coordinate, x2 minus x1. Okay, x2 minus x1. And then the height, use the y coordinate. Okay, this is y2 minus y1. Y2 minus y1. Okay, so this is how you get this formula. Okay, then they rearrange. Okay, they expand it and then they rearrange. Okay, this one I don't want to go through so detail with you. You can do the expansion by yourself. Okay, and then they just how to say, simplify it. Okay, and then end with this formula. Okay, but you are not going to memorize this formula. Okay, but there is a technique of writing it so that you can do it easily. Okay, so this is a this is a way that you can write. Okay, and then you just remember this way. Okay, and then you can get the area easily. Okay, so now we see okay, so actually this one is from just now from this. Okay, it's come from here. Okay, if the question asks you to do this then you are able. Okay, okay, so this is how you write. Okay, so this is the first pair. Hey, can you hear me?
And
Yeah,
teacher.
can.
Okay. Sorry. Suddenly like that. Ayo. Where do I stop? Okay, here. So just now until where I? Oh, I didn't share, is it? With her? Ayo. Okay, can see the textbook?
Yeah, can.
Where do I stop? Is it here? This one okay or not? Someone?
Finishing this one.
Okay, this one finish. So we come to here. Okay, so now I want to guide you how to write in this way, so that you can get the area of the triangle when the vertices are given. Okay, so this is the first point. Okay, you list out this way. Second point, third point, and repeat the first point. Okay, and then you put the modulus for it. Okay, I will tell you afterwards why you need the modulus. Okay, and then first, okay, you draw arrow, the red color one, okay, pointing down. Okay, this one means your x1 times y2, your x2 times y3, and then your x3 times y1. Okay, this is a meaning. Okay, and then get the total of it. Okay, the sum. Okay, with the sum of the all products in this direction is given the positive sign. Okay, this one positive. Okay, and then the one blue color and then dotted pointing out one, this one give negative sign. Okay, so this one means y1 times x2, y2 times x3, and then y3 times x1. Okay, we see the summary. So this is a summary. Okay, you don't have to memorize this. This one actually is quite easy. Okay, after when I show you the example with number, okay, then maybe you are more clear. Okay, so you see, okay, look at this. Okay, shoe-race algorithm. Okay, this one we call it shoe-race algorithms. Okay, and then if you arrange, okay, the vertices are in anti-clockwise. Okay, this one will give you the area is positive. Okay, means if you arrange the coordinate in a clockwise, this one will give you your area in negative. Then with the modulus, you turn it into positive because area cannot be negative. Okay, so this is the purpose of the modulus. Okay. Okay, and then this one, this formula can be initiated by choosing any one vertex. Okay, like example just now, okay, this diagram, okay, the ABC, okay, if ABC this way you arrange it, it will be anti-clockwise. Okay, so suppose the area that you will get the final answer is positive. If you didn't get positive, means something wrong already. You make mistake in your calculations. Okay, so you can put the point A as a first point. Okay, means point A, point B, point C, and then repeat point A. Okay, if you don't want to put this way, you can put point B, point C, point A, and then point B. Also can. Okay, means which point you decide to use as the first point is up to you. Okay, but if you do it in anti-clockwise, this is anti-clockwise. If BCA is still anti-clockwise, clockwise this way. Okay, anti-clockwise, then you will still get a positive answer in your area. Okay. So this one. Okay, so for this, I want you only copy this in your notes. Okay. And then you can copy this. Okay, anti-clockwise is positive. Okay, now we look at the one example. Okay, look at this example. Okay, so given point A, point B, and point C. Okay, if you are not sure how they will appear, Okay, if you don't want to or lazy to draw out the diagram, you don't care about the anti-clockwise and the clockwise. Okay, you just do. Okay, if you get negative, then at the end with the modulus you will make it positive. Okay, that's all. Okay, but this one they show in diagram, they just want to prove to you if they do clockwise and anti-clockwise, what will happen. Okay, so roughly sketch in Cartesian plan, okay, point A, B, and the C. Okay, so this one they do it in this way, anti-clockwise, start with the point A. Okay, -4, -6, this is point A, and then point B, and then point C, and then repeat the point A again. Okay, and then this arrow, red color, pointing down. Okay, you just get the products, and then the total of it, sum of the product. Okay, so this is -12. 5 times 8 is 40. 2 times -6 is -12. Okay, this one you make it positive. You see in front got nothing, is positive. Then the blue color one, you make it negative, so you minus. Okay, so same thing. Okay, get the sum of the products. So -6 times 5 is -30. 3 times 2 is 6. 8 times -4 is -32. Okay, then you just get this whole thing minus this whole thing. Okay, then divide by 2. Okay, then this one is your answer. Okay, so you see for if you arrange the point anti-clockwise, you are getting positive. Okay, now they tried another way. Okay, they arrange it clockwise. Okay, so this is point A, this is point C, this is point B. Okay, A, C, B. They do it this way. Okay, so it's clockwise. Okay, and then repeat the point A again. Okay, so for this, you will get negative. Okay, then you modulus the negative value, okay, change it into positive. Okay, either way. Okay, so if you are lazy to draw out or sketch the point, okay, just choose any. Okay, if you choose point A be the first one, so A, B, C, and then repeat A. Okay, if you choose A, C, B, and then repeat the A. Okay, don't care. Okay, but remember, if they give you negative answer, remember to change it to positive. Okay, that's all only. So this one. Okay, there is another way of finding the area of triangle. We see this. Okay, beside the shoelace algorithms, the box method. Okay, this one they call it box methods. Okay, they use back just now the example, example 8. Okay, this one with number easier rather than just now the x1, y1, that one are more difficult. Okay, this is another way for you to get the area of triangles. Okay, so you draw a rectangle that touches every vertex of the triangle. Okay, mark the triangle formed in the box with 1, 2, 3 as shown in the diagram on the right. Okay, so it's very simple. If you want to find the area of a triangle, this one, okay, you just get the area of a rectangle minus these 3 triangle, triangle 1, triangle 2, and triangle 3. Okay, you just get the area of these 3 triangle. Okay, then you will get the balance. Okay, which is the area of triangle ABC. Okay, so step 2, find the area of rectangle. My multiply is length and by width. Okay, so from here to here, same thing you need to find okay, if this is coordinate, then you use a coordinate This is x and the x. So x coordinate for this point, so this is 5. Okay, and then this is -4. Okay, so you get 5 minus -4, so here is 9. Okay, and then this one, the length from here to here. Okay, same thing, I need the y coordinate for this. This is -6, and then for this point, okay, this is 8. Okay, so 8 minus -6, therefore is 14. Okay, so this is how you get the area of rectangle. 9 times 14. Okay, so 126. Okay, step 3, you find the area of a triangle 1, triangle 2, and triangle 3. Okay, so same thing one by one okay, you have to get the length Okay, this one 14 is from here to here. Okay, look at the first triangle. This one I already have. This is 9. Okay, now I need this. Okay, so I use this. This is 3. Okay, and then this is -6. So 3 minus -6. So this is 9. Okay, so 9 by 9. The base is 9, the height is 9. Okay, so 9 by 9, okay, and then times half. So this is the area of the first triangle. Okay, second triangle, do the same thing. Third triangle, do the same thing. Okay, then you just minus, subtract. Okay, subtract of the area of triangle of them in step 3 from the area of rectangle to determine the area of triangle ABC. Okay, so 1 to 6, just minus these 3. Okay, then you will get the answer. Okay, so this is another way, okay, of getting the area of a triangle. Okay, now we go to example 9. Okay, look at this. Okay, the coordinate of the vertices of a triangle ABC. ABC. Okay, C don't know. Okay, C the x coordinate don't know. Okay, if the area of triangle ABC is 18, area is given. Okay, so find the possible value of the K. So you see, the C can be here and then the C also can be here. Okay, so this is why you need the modulus. You still remember the modulus can bring two meanings. One is positive, one is negative. Okay, so you just use a formula. Okay, so 8, 5, okay, -2, 3, and then K -1. Okay, so you arrange point A. This is point A, point B, point C, and then repeat point A. Okay, and then use just now, okay, the methods. Okay, coming down is positive. So -3 times 8, -24. -2 times -1 is 2, positive. K times 5 is a 5K. Okay, minus, okay, this one is all the negative one. Okay, so -2 times 5 is -10. Okay, -3 times K is -3K. -1 times 8 is -8. Okay, you just find the products of each of these. It's just the one going up one. Okay, just now the blue color one. Okay, you make a negative in front. Okay, and then put bracket. Okay, and then down one, the red color pointing down one. Okay, in front is positive. Okay, so this one you have to write out the plus minus. It because I don't know whether the C is this side or the C is this side. Okay, if C is this side, A, B, C, this is anti-clockwise. Clockwise. So this one will give you a positive. Okay, if C is this side, then you are getting A, B, C. Okay, then this is clockwise. Then this one will give you negative. Therefore, you have a negative and the positive. Okay, this one, the purpose for you to get plus, for you to put plus minus is because you need to find that two possible points. Yeah, so now, okay, you will have end up with two answers. Okay, so one answer is the K is -4, so it's here. Okay, then the other answer K is 5. Okay, so it's here. This is C2. Okay. Okay, next, I want to go through this one. Okay, how about this? Okay, what can you say about the 3 points if the area of this is equal to 0? Okay, what you can say about these three points? Okay, area is 0. Yeah, so I'm going to show you this. Area is 0. Okay, this one actually more than 3 points. This is quadrilateral. Okay, but the same idea, Okay. Okay, what is the meaning if the area is equal to 0? Okay, so now I'm going to move. Okay, Okay, let's say I move this point. I want to make the area become smaller and smaller, ma. So I move it. Hey, this one is look like a triangle already. Okay, I move some more. Hey, girl, can see, huh? Is it can see? Someone on the mic? Okay, so now I want to move the point C. Ayo, but the point B, point D disturbing me. Okay, I move down the point D. Cannot, meh? Oh, I know already. I have to unselect this point D. Ah, yes. Okay, now you see, it's almost 0 already, I will try. I don't know whether I can get or not. Oh, very, 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 very near. I can't get exactly 0. Okay, but it's very near to 0 already. You want to help? Maybe it's point D or maybe it's point C. My son is helping me. Ah, okay, very good. Thank you very much. Okay, so he managed to get 0. Okay, orang tua cannot control the cursor. Okay, so now you see, when you get the area is 0, what happened to these four points? Okay, the A, B, C, D. You assume this is 3 points. How many points also doesn't matter. Okay, when the area is 0, you will see all the points actually fall in a line. Okay, this one we call it collinear. Okay, the point are collinear. Okay, so I have answered just now these questions. Okay, what can you say about the 3 points if the area is 0? Okay, if the area is 0, the 3 points are collinear. Okay, so this is the answer. They are collinear. Okay, this one you have to put into notes. This one. Okay, this one is because sometimes the question will do ask. Okay, they will say ask you to prove. Okay, the points are collinear. This is one of the method that you can use. Okay, I remember last time I don't know whether you're aware or not. Another way of proving this is collinear is by using the gradient. Also can. Okay, the grade you have to find the gradient. Okay, of the points. Example, point A, point B, and point C. A, B, and the C. You find the gradient of the AB, and then you find the gradient of the BC, or you find the gradient of the AC. Either two. These three, you find either two, and then show they are equal. Then they are collinear. Okay, also can. Okay, so there are a few methods that you can use to prove the points are collinear. Okay, so this is two of the methods. Okay, so I think that's all.
Teacher.
Yep.
So collinear is the gradient same.
Yes, because they are in the same line.
So
Same line,
meaning
the gradient will be the same.
they are in a straight line, not polygon.
Yes, correct. Okay, they fall into straight line. Like just now, you see this one. When I move until the area is 0, you will see that 4 points are actually fall in a line already. You can't see a polygon because the area is 0, means actually no area. Okay, so you only see a line, a straight line. Okay, therefore this one we will say that point A, B, C, D actually they are collinear, means they are fall in a straight line.
Okay, teacher.
Yeah, okay. Okay, so I repeat now, when the question asks you to prove the point are collinear, there are two methods. It's either you find the area, okay, of the points, okay, then proof is equal to 0. Then so it's proven it's collinear. Another way is you find the gradient. Okay. Example, this is point ABC. You find the gradient of AB, BC, AC. These three you'll find any two. And then if they are the same, then they are collinear. Okay. So today you just do this. Okay, you just do this exercise. Okay, this is the one. This question 5. This one is same as the example 9. Okay, the possible values means the k got two value. Okay, so remember this one. Okay, you have to put plus minus for your area. Okay, so that your k will come out with two values. Okay. This is the one you see. Show the points. These 3 points are collinear. This type of questions. Okay, so this one, if in this topic you can use find the area. Okay, of this point. Okay, let's say this is ABC lah. Okay, area of triangle ABC. Okay, if you can show this one is 0, okay, then you can make the conclusion, okay, this is collinear. Okay, then the other way around. Okay, they give you these 3 points are collinear. Okay, find the value of P. Okay, means if you already know these 3 points are collinear, so okay, you know that their area E, F, G, okay, is equal to 0. Okay, then you use the formula of area of triangle. Again, then let it equal to 0. Okay, this one got no two value. This one is only one value. Okay, it's because 0 there's no plus minus. You have a positive 0 and you have a negative 0 are the same. Therefore, this case is only one value. Okay, it's different from the case number 5. Okay, you can see the difference. Okay, this question number 2. They say the third point, the vertex R is on the x-axis. It's on the x-axis. This is x-axis. Okay, maybe point R is here. Okay, maybe point R can be here. Okay, x-axis. So the y coordinate is 0. Okay, so you can put x and then 0. Okay, for coordinate R. Okay. Find the coordinates of R such that the area is 10. Okay, I think this one you have to you have two values. Okay, for the x. Okay, same thing. You got to put plus minus for the area. Let me check. 7.6. Correct. Okay, coordinates. Okay, so there are two possible values. Okay, for this x. Okay, so I think that's all for today. So I will see you tomorrow. Okay, wait for Vala.